So now we're going to talk about something called hemostasis. And basically that means blood clotting. Literally, it means stoppage of bleeding. So blood clotting utilizes little cells, which aren't actually cells, are actually cell fragments, and these little cells are called thrombocytes. Sorry. My spelling is not good tonight. So thrombocytes, and you're probably more familiar with the word platelet. And we need platelets in order to have blood clotting. So platelets come from a cell it's a white blood cell called a megakaryocyte. And this is a big old cell in the bone marrow that comes from a hematopoietic stem cell. Remember, hematopoietic stem cells, once they decide where they're going, that's where they're going. If they're going towards making an erythrocyte, they're going to make an erythrocyte. If they're going towards making a lymphocyte, that's what they're going to make. And sometimes they make these cells called megakaryocytes. And these are huge cells in the bone marrow. And when they try to enter the bloodstream, when they try to enter the bloodstream, they can't fit. They can't fit through and to get in there. So what happens is the blood that's rushing by takes off little pieces of cytoplasm from the megakaryocyte. And those little fragments are platelets. And fortunately, the cytoplasm has all the little constituents needed to do blood clotting. So that ends up within these fragments. The fragments, they live about 5 to 8 days. And the normal count in a person, normal platelet count is about 150,000 to 450,000. All right, so hemostasis. Hemostasis literally means stoppage of bleeding. And that's a pretty important thing. We don't want to bleed to death if we cut our finger or something like that. So, so we're talking about stoppage of bleeding, from damage, right? So if we have, a little blood cell here, we got to cut, let's say, in that blood cell or blood vessel, okay? And the epithelia, that the epithelia from the blood vessel is cut, and what it does, it starts to secrete chemicals. So there's an area here around the injury site, and it starts to secrete chemicals. And the first thing that happens from this injury is what we call a myogenic response. And the myogenic response, think myo, so that's muscle. So this is a smooth muscle contraction. We call that vasoconstriction. So this vessel then vasoconstricts. It gets smaller, the lumen gets smaller, and that slows the blood coming to this area. And that gives these chemicals that are being released here a chance to get out there to alert platelets. Okay, so we slow down blood flow and the chemicals start to activate platelets. So chemicals from the injured area start to activate platelets. And once a platelet is activated, it starts to produce, so an activated platelet produces a chemical called thromboxane A2. So thromboxane A2. And thromboxane A2 is a vasoconstrictor, so it helps that. And it activates more platelets. More importantly, it activates more platelets. Okay? So what does an activated platelet do? Well, of course, they continue to activate more platelets. We're talking about a positive feedback mechanism going on here. So it's activating more platelets, but they also, an activated platelet starts to grow. They get bigger. They get weirdly shaped, so irregularly shaped. So they get all these weird shapes, they're getting bigger, and they also get real sticky. So they're getting sticky, they're getting big, they're getting weirdly shaped, and they stick together to form what's called the platelet plug. As they're activated, of course, they're still making, active platelets still make or produce thromboxane A2, so that's going on as well, but we're making this platelet plug. So the platelet plug is a temporary plug over the injury, which stops bleeding. But I said temporary. This is a temporary solution. It is not going to be strong enough to hold there for healing to occur. So after the platelet plug is formed, now we have to go through clot formation. So part 2 of this will be on the next video, and that will be clot formation. So stay tuned.